putting it all together. Introducing the assembler of choice, 64 tasks. There is a link to the binary downloads in the description down below and a link to its extensive documentation. It runs on everything, as it is pure ANSI C. There are people that run it on Amiga 500s, everything. Well, anything with at least a couple of megabytes of RAM. This is a very unique assembler, in that it's an assembler with an internal linker, which won't make much sense, but eventually will click. This means it does everything in one step, and there is no config. Unlike WLADX and CA65, which has an assemble and then a link step to build a file, 64 tasks will make it all in one single call. First up, the structure of my files. There is the master.asm file. This includes everything, places everything in memory, and the file we assemble. I like the file per bank approach. It keeps the, if it's not in this file, it has to be long, clean. But you can then put subfiles into those bank files, so you don't have to only have one file per bank. Just the file acts as the collector for all subsystems and units you want. The 64 task linker is not a traditional linker, so it doesn't do the random placement for you. You don't say, here is an object, fit it into a bank somewhere, and tell me where it is. 64 tasks will ask you to tell it where you want things. We can make sections and we can instance those sections somewhere. However, we can haphazardly place things in a section. This will make more sense when we step through the code. Let's dive into master.asm. First up, we tell it we want a 65816. It saves us from doing it on the command line. Now we start at 0 in the output file. Then we tell the assembler that this is logically 8000 in bank 80. At this point we are at 0 in the assembled file, but when it assembles code, it will assemble it as if it is in bank 80 at 8000. If we inspect the asterisk, which is the PC, it will tell us that we are at 88,000. Now I instance a section called sbank80, S for section, and I'm just calling the first bank, bank 80. I want to make sure this bank doesn't overflow, so I have the assembler check for me. I.e., if we go past FFBO, then we have gone too far. That is where the internal header resides. Now I move the logical PC to 80FFBO. I instance a section called sHeader, which I will later fill in with my header information. Then we move to FFE4 and instance the native vectors. Then move to FFF4 and instance the emulation vectors. We are done with this bank, so I close the logical address with a dot here. Now the asterisk represents the file offset again. First bank done, now on to the next. I snap to 8000 in the file to be sure. Logically this is 81,8000. I instance section sbank81 here to go back to the file space. And I check to make sure we have not gone too far. Again, this is in file offset. And then bank 82. And so on until you have all the banks you need. You don't need to pre-add them. Most emulators will handle not power of 2 ROM files. With the SNES to file mappings dealt with, we can now move on to the machine only ones. So again, we move back to 0. And I instance the DP section. I make sure that we have not overflowed our DP. Then the shared RAM section. This is what I like to call the lower 8K of RAM. I am limiting it to 1FCO to give me a bit of stack. 64 bytes is probably enough for me. The 65816 does tend to use stack more than a 6502, so I might need to revisit it later once I have a better feel for my stack use. Then we move to the not mirrored 70 WRAM bank and make sure we don't overflow. And then the upper WRAM bank at 7F and make sure we don't overflow. We told the assembler where we want things, time to tell it what things. open section SDP. I add my standard temp variables. These are global and used by everything, so I add them here. We also need to fill in the header, as described in the previous video. And the vectors. Note the V in front of cop and break. They are opcodes and will error without. Also, since we are doing .word and we are not in bank 8 logically, we have to add the getWord operator to them. If you don't do this, you will get an error message such as this one. This is telling you the assembler is convinced that for your current bank and databank settings, this address cannot be seen with a word address and needs a long address. In this case, it's because we are in databank 0 while the code lives in bank 80. If you get these errors, double check and be sure before adding the override word operator. The assembler is trying to help you. Let it. On to the banks. B-include pulls everything inside it into a block. A block is basically a namescope. Sections collect things together but don't add a namescope. Blocks do. This avoids any name clashes across the project and means if anything wants to address it from outside of the bank, it must use bank 80 dot, which helps avoid JSL/R bugs, as I will demonstrate later. On to bank 81, here I include 2 files for effect. On to bank 82. Since this is my last, I union it with 32K of AA, so the output file will have all of the final bank. There are other ways, I've just chosen this one. And I include a binary file for completeness. I also define a couple of new types. High-low word. This joins a word access with low and high named indexes. And high-low bank long. This joins a long access with a low-high bank, low word, and high word named indexes. You instance them using the .dunion command. This makes the code much more readable. For example, to get the high, you normally do +1. Now you can do .high. For a long, you can do .bank, not +2. Never accidentally write +3 again. Which one of these next two shows your intent better? And that concludes the master.asm. It's the spine file. Let's move on to bank 80's code. The SNES is unique in that it has a lot of mirroring. The other 65816 machines don't have any. Thus, 64TAS doesn't have built-in SNES addressing. We have to fake it. To do this, we have to add the shared WRAM and registers if you like into the current bank. We do this with a virtual operation. This tells the assembler, pretend this is here, but don't actually put it here. So we take the start and offset it to this bank. Then instance the section. Now the assembler will see each of the things we have in the shared RAM as being in bank 80 and automatically drop to word addresses when it can. We don't need to do this for the DP, as the DP is always in bank 0. First thing I have is reset, so I configure the assembler to reset conditions, 8-bit everything, all pages 0. Now this is the reset I've shown before, only now I don't need to add 8000000 to the address when jumping because the address is already in bank 80. Once we have done the PLB, I set the assembler's databank to be 80. Note now I have put 80 in front of the register's addresses. This is because we are now in bank 80 and I'm directly accessing it via hex address. So if you don't put 80, it will think you want 002100 and it will do long addresses, which will fail on the STZs. Why am I using direct hex address and not a label? Because I don't want to access the addresses too often. They should only be touched by the mirror setting code and in a few other instances, such as specific DMA routines or the VRAM DMA pump. This way I can't accidentally type one that doesn't have M or mirror on the end and accidentally write directly to the address mid-frame. It avoids the bug. This is all as shown before, nothing too fancy. One nice thing about having the section is you can open a section anywhere and add things to it. For example, I want the NMI done flag, and for now I think it would be nice to have it in the direct page area. This is a minor variable that only the NMI and main loop will probably ever want to touch, so it is nice to declare it near both pieces of code. I also want my mirrors. These should just be in shared for now. So I'll open the shared section and add them. Again, this allows me to add and declare variables near where they are consumed. Rather than having a large file that has every single one in it and you have to hunt and find it each time you want to add one or remove one. This feature will come in handy when I show you the fixed databank technique in the next or maybe the one after video. I don't make promises on these things anymore. I just declare a word for DMA clears. Then onto the NMI handler, where it is as it was before, just except you need to add a comma B on the end of the NMI ready NF. As I want to be able to access it as a word, only it's not in this databank, it's in bank 00s because it's a DP variable. So I use comma B to override the warning and to tell it that it's fine and to just trust me on using only a word. The other files are just something. NM code, I'll add a function into it. This is just a dummy function. However, I wanted to highlight how to set the databank to whatever bank I'm in. The nice thing about sections is I can move files from bank to bank as I see fit. I don't want to have to hard code the databank setting. The backtick gets you the bank of an address and the asterisk is the current PC. So databank, backtick, asterisk will set the databank to whatever the current program bank is. You assemble with this 64-A for ASCII text input. -X. The capital is important. This tells 64-TAS we want a 24-bit file size. -B, as we are not making a super CPU file and we don't want a Commodore PRG header, but a plain binary file. -O and the outname file. -L, again capital is important. You want a listing file. And then the main file, master.asm. And you'll get something that looks like this. Having sections means we get a nice itemized list on how big each thing is. For example, Bank 80 currently has 327 bytes in it, and I have 7 bytes used of the DP, 68 bytes of the low shared, and my low WRAM and high WRAM are empty. Let's add a JSR call to that function I put in anim code, and assemble. It doesn't know about it. This is because we are in Bank 80 block, not the anim code block, so it can't see the label. We need to add the scope, and we still fail. In case the fact that I had to type another scope and I have a leading L on the function name didn't make me twig that I need the JSL, not JSR, now the assembler will strictly tell me it's 81, not 80. That is it for this video. Next video I will be looking at best practices and other hints and techniques and other ways to exploit 64-TAS to make your life easier. And I've uploaded the code set from this episode up to GitHub so you don't have to sit there and type it in all by yourself. That would just be pointless. Anyway, see you next time.